We have one more lesson to learn. Now you know that the page number's not right. Oh, snap. Did it again. Did you say 135? We're going to graph rational functions that have holes in them.
Have what?
Holes. They have holes in them. Yep. Now listen to me. This is exactly what we've been doing for the past 2 days with one extra step. One. So hopefully this will go pretty quickly for you. I'm sorry. It's the same thing as the one before, except it says with holes on the end of it. Everybody good now? Okay. Now, we are not going to do those two review problems. So go to the next page. Before we even talk about the stuff that goes in those blanks, what I want you to do is get on your calculator, go to y equals, and I want you to type that in to y1. I don't know if the calculators on your phone, do they do the alpha y equals with the fraction? Please use that. No, I do not. That recording. Now, heads up. We're going to look at this fraction before we go on and do anything else with the graph. If you'll notice, the instructions say find the common factor. So what you're needing to do is factor the top and the bottom. So let's factor the numerator. How will that numerator factor? Okay, x plus 2 times x minus 3. Yeah. And then, how will the bottom factor? X minus 3 times x minus 3. Right. Huh. Well, that's kind of interesting. So x minus 3 is a common factor. You can factor that out. Now, we didn't have any of those yesterday. So this is just x plus 2 over x minus 3, right? All right. Now, we're going to end up taking this graph out. It's not set up to do what I want it to do. But you see about the graphing out or factoring out the common factor. Okay, what about B? Does B have a common factor? How does the numerator factor? Mm-hmm. What do you see? So what are you left with? That's it. The ones you're going to do today are going to factor. Plus 4. The ones you're going to do today are going to factor, okay? Now, so the question is, when they factor, what does that do to the graph? That's the big question for today. Is that the next page? Yeah, I don't want to talk about that yet. Okay. Let's talk about number 1 here. Anytime you want to graph, the first thing you want to look at is, will the darn thing factor any? Go. Go. Good. Well, stint it, you're an idiot. You're right. I got it. I don't know, yeah. I did, yeah, I suppose. I did get more sleep. I did. Snap. So I got that fixed up. Now, I'm going to pause this for just a minute because I'm going to go to my calculator. Now, what I want you to do, I want you to type that into your Y1. Once you have it typed in, I want you to graph it, but I want you to graph it in a special way. I want you to do zoom 4. Zoom 4. Oh, whoops. Now, that's a line. What? Do I? Sure, sure. Now, you got a line. How in the world does an equation... That's right, Trent. It's because after you factored out the common factor, look what we were left with. F of x equals x minus 3. Now, what does f of x mean? What? Look. It's y equals x minus 3. That's the picture you've got on your graph. What's the y-intercept? Oh, negative 3. What's your slope? Where is slope? Where is slope? Mx plus b. It's the coefficient of the x. That's what you've got on your graph. Oh my gosh. So what does this do to it? Does that not do anything? Now, let's look at your calculator. I think holes are pretty cool. Now, when you have a factor that factors out of the numerator and denominator, it does something funky to your graph. Now, the reason I had you to do zoom 4, if you are able to factor out a common factor between the top and the bottom, zoom 4 is going to be the only place where you can see the cool thing that happens. Now, you're like, I don't see anything cool except it's a line. I don't see what's cool about that. I want you to do this. I want you to go to window. Now, does your window look like mine? Now, because I know where I'm looking, I want you to do this. I want you to go down to Y min, and I want you to arrow to the end of the number negative 3.1. Do you all have your cursor there? Do times 3. I will explain to you in a minute. Now graph. There's a hole right there. You can't see it? Ah, okay. Can any of you see it on your phone calculator? No? Okay. You can see it on the big calculator, on these. You can see it. Now, ladies and gentlemen, when you are able to factor out a factor between the numerator and denominator, your graph has a hole in it. We'll talk about that again in just a second. Now, here's what I want you to see. For those of you who you can't see the hole, don't worry about this. I'm going to go down to my Y2, and I'm going to type in the stuff that I had left, which was what, x minus 3? Now, what I want you to do, I want you to watch, and I want you to specifically watch where that hole was. Watch where the hole was. What? It got filled in. It got filled in. Now, that hole, you don't know what the coordinates of that hole were, do you? Here's what I want you to do, and this should work on even on your phone calculator. go to table, which should be second graph. Now, I want you, find out where you have an error. You have an error at x equal -4. Why do you think you have an error at x equal -4? That's right, because this was x plus 4 times x minus 3.
So is the whole just a denominator?
The whole is what makes that factor that you factored out equal to 0. So I have a whole when x is -4. Now, look at your table and see if you can figure out what you think the y value ought to be. Why do you think -7? That's right. That's right. Now, the question is, how can I prove to you, because you have little faith, that that y value really is -7? Well, remember, when we factored out the common factor, we were left with x minus 3, right? What do you get when x is -4? What's -4 minus 3? -7. -7. That is the one difference from the stuff we've been doing the last 2 days. Everything else is the same. I like holes. I like holes.
So the one thing, is there like,
This is the one thing that's different from the last 2 days.
so, I'm trying to think of how to word this.
Okay?
So pretty much, I guess what you do is like find what makes a factor 0. So in this case it's -4. And then you just subtract it from the common denominator.
To find the y value? To find the y value, you put that -4 into what was left after you factored out the x plus 4.
Okay.
You just put it into what's left. Now, let's talk about the rest of the stuff. This was -7, don't lose that. Now, let me neaten this up just a little bit. So we had f of x equals x minus 3, right? Now, so let's go get our zeros. So we're going to do just what we've been doing. Now, to find these things, I'm going to look at what I've got left, okay? Zeros. Do you remember how to find zeros?
3 is one of them.
One of them? How many times does that graph cross the x-axis? Just one time. Just one time. Remember, a function is equal to 0 when the numerator is 0. Well, I don't even have a denominator, right? So it's just, when is x minus 3 equal to 0? When x is 3. Now, ladies and gentlemen, you know that that's a line, right? This is not a rational function because there's not a variable in the bottom, because there's not a bottom, right? There's not a denominator. So I don't have vertical and horizontal asymptotes because I don't have a denominator with an x in it. So I don't have anything there. I don't have anything there. So you say, well, Ms. Dennett, how do you graph a hole? You graph a hole just like you think you'd graph a hole. You go to -4, -7, and you put an open circle. Now you know how to graph that. You know how to graph this. Your 0. This thing crosses the x-axis right there, doesn't it? What's your y-intercept? -3. What's your slope? one. Up one, right one, up one, right one. And then you've got your graph and you've got a ruler. And now look, when you hit that hole, just lift your pencil. Do so. Now look down here. The function that remains is a linear function. It's a line, but that's not always the case. That's not always going to happen. Let's go back and see if we can fill in some of this stuff. Some rational functions produce, everybody see where I am? A hole in the graph. This is sometimes called a discontinuity. Guys, all a discontinuity is a place where you have to lift your pencil when you're graphing. It's just a place where I have to lift my pencil. These occur when there is a common factor in the numerator and the denominator. That particular value on the graph is not part of the domain. Okay. Now we had this box right above the graph we just did, yes? So to graph a rational function with holes, you factor the numerator and denominator. You find the common factors that factor out. You graph what's left after you cancel those out. And then you find all your stuff. All right. Now, one thing we did not address yesterday and the day before, we were just time crunched. Let's talk domain. Bless you. Is domain X or is domain Y? Good. Domain is X. So remember, domain, you're going to read left to right. And the question is, are there any X values that have to be left out? That I cannot use in this problem? Right. What's the X value of that hole? -4. But see, I can use every X value here except -4 because -4 makes my denominator equal to 0. So you're going to say the domain is from -∞ to -4. Now remember, we used this notation before, yes? Now -4 can't be used, so you got to put a parenthesis around it. Now, did we do this notation?
No.
It's a U. It means and, but you don't have to worry about that. Did we just do this? -4 to infinity. So that means the only number that's left out is -4. Now, what you might have thought when I said -4 makes the denominator 0, you may have thought, wait a minute, Stennett, you said that that meant a vertical asymptote. When your denominator is equal to 0, you have either a vertical asymptote or a hole, one of the two. It's a hole if you have a common factor that factors it out. It's a vertical asymptote if it doesn't factor out. Range. Range is the Y values. Read from bottom to top. Do you see any Y values that have to be left out? -7 has to be left out. So we're going to go -∞ to -7, and then pick up on the other side of -7 and go to infinity. Next page.
You go back to
No, you do not have to put a bracket because those numbers were left out, and left out means parentheses. Okay, now you got the idea. Now let's give this one a whirl. How many of them are there?
4.
4? We won't do 4. We'll get 3 of them. Okay. Now, so when you are graphing a rational function, the first thing you're going to do is see if that thing will factor. Will it factor? We're sure going to try. Denominator's a difference of 2 squares. You have a common factor that you can factor out. X minus 2, good. As soon as you have a common factor that factors out, you say, I got a hole, I got a hole. What X value makes that thing you factored out equal to 0? The X value of your hole is 2. Now let's look at what we've got left. We've got 2x minus 1 over x plus 2. To find out, bless you, to find out the y value of the hole, plug that 2 into what you got left. What's 2 times 2? Minus 1. 3 over 2 plus 2. So 3 over 4. So your hole is right there. Now remember, zeros were left off. Bless you, dadgum. Everything else I do is going to come from this simplified fraction. A fraction is equal to 0 when the numerator equals 0. Good. When is 2x minus 1 equal to 0? Add 1. Divide by 2. So I have a 0 when x is half. Vertical asymptote happens when the denominator is 0. Vertical asymptotes when the denominator is 0. Is this denominator ever 0? When x is negative 2. So x equal negative 2. Horizontal asymptote happens when you compare the degrees. What's the degree of the top? 1. What's the degree of the bottom? 1. Biggest exponent. What? So the coefficients, 2 divided by 1 is 2. Y equal 2 is your horizontal asymptote. All right. I'm gonna rewrite this. We got a sneezing fit going on if you're watching this video. All right. Put in what you got. We've got a 0 at x equals a half. Right there. We've got a hole when x is 2 and y is 3/4. Now the best you can do is the best you can do. There's a hole. I've got a vertical asymptote when x is negative 2. And I've got a horizontal asymptote when y is 2. Do you have questions? How many pieces has this vertical asymptote broken the graph into? Just the vertical. I don't care about the horizontal. Just the vertical. 2 pieces. So what we need to do is we need to find some points left of the vertical asymptote and right of the vertical asymptote. Let's go left. I want you to pick 3 numbers that are close to that vertical asymptote, but on the left side of it. What was that, 2x minus 1 over x plus 2? Have I got that wrong? Is that? Okay, so negative 2 is your vertical asymptote, right? Negative 3, negative 4, negative 5. Then go over to the other side. I've already got 2. I need 1 more. What do you want to do? I'd use 0. I'd use 0. I've already got 2 points, so just use 1 more. Just use 0. Go to your table on your calculator and find those y values. Oh, you got to put the equation in, don't you? Yeah, put the equation in, shall you? All right. What if x is negative 3? What's y? 7. Go. Come on.
What was that? 3.66 repeating.
3.6. Don't put repeating. If you put 3.6 or 3.7, I will not fuss about either one. When x is 0, negative a half. Plot those points. Negative 3, 7, negative 3, no, 7. There's negative 3, 7, negative 4, 4.5, negative 5, 3.7, and 0, negative 1/2. Do you have a pretty good idea what this looks like? Here, arrows. Here, arrows, but don't go through that hole. Do not go through that hole. Now let's get our domain. Remember, we're reading left to right for domain. Left to right. You're starting at negative infinity. What's the first x value that's left out? Negative 2 is left out. Then we pick up on the other side of negative 2. 2 is left out, right? Because 2 is the x value of the whole. And we skip over that. And then we pick up and go all the way to infinity. Does that help? Is that making sense? Now, range, y values. I start at the bottom, and I'm going up. Where's 0.5? Why 0.5? What's the y value of the whole? 3/4. Yeah. So negative infinity to 3/4. I got to skip 3/4. Then I start again on the other side of 3/4, and then where's my next barrier? 2. So I got to skip 2, and then 2 to infinity. There you go. Guys, you can do that one. You can do them all. Good. So we're going to do, I'd like to do 2 more, if we can, 2 more. Let me see. We're for sure going to do number 5. Yeah, let's do 4. Let's do 4 and 5. You have a question? Are you good? Number 4. what I want you to do, factor. Go. How'd your numerator factor? Good. X minus 3 factors out, cancels out. What are you left with? Wait a minute. Wait a minute. That's great. That is similar to a problem we've already done. Because y equals x plus 3 is a line. Is a line. Okay. Now, is a line with a slope of 1 and a y-intercept of 3. It's just a what? That's right. There are no vertical and horizontal asymptotes. The only weird thing about this one is because we factored out a common factor, this sucker's got a hole. Now, where I'm checking every time I see, I'm just checking to see if it's something I can share with you. So I don't have any horizontal or vertical asymptotes, but I got a hole. What is the x value of my hole? The x value of my hole is 3. What's the y value of my hole? No, put the x value of my hole into what's left. 3 plus 3 is 6. Yeah. 3 plus 3 is 6. That's my hole. Where'd you get negative 6?
I was thinking.
Yeah, but
I realized 3 and then x. I thought that was negative 3 plus 3, which got 0. So then I did negative 3 plus negative 3. Got negative 6.
Okay. Okay. Zeros. Now, because there is not a fraction, remember, in a fraction's equal to 0 when the top's equal to 0, but I don't have a fraction. So the question is, when is x plus 3 equals 0? When x is negative 3. I know everything I need to know to graph this bad boy now. I'm going to put this over here so I can get it off the graph. Now, you got a hole at 3, 6. You go up there and you put yourself a hole at 3, 6. I have a 0 when x is negative 3. And I got a line. What's the minimum number of points you need to draw a line? 2. I got them. I got them. I don't have to do anything else. Draw your line. Just don't draw through the hole. Just don't draw through the hole. You feeling it's okay? All right. Domain and range. Is the domain x or is the domain y? Domain is x. Do we read domain from bottom to top or from left to right? Left to right. So we're going left to right. We're starting at negative infinity. Do I have any x values that give me a problem? X equals 3 because that's the x value of my hole. Leave it out because we got to get over it. Pick up on the other side of 3. And I don't have any more problems, so we're going to infinity. Range goes bottom to top because it's y. We're starting at negative infinity. Don't have any problems here. Pow! 6. Jump over it. 6 to infinity. There you go. You're doing good. You're doing really good. Now, we're at least going to get this one going. You'd rather not? Yeah, you probably rather would. we can at least get it factored, eh? Eh?
Ready?
Eh? You just looked at it and you don't like it. Will that numerator factor? How? X minus 2 times x minus 1? Look at the denominator. How many terms do you see? 4. There's a word that we used to factor 4s. No, it starts with a G. It starts with a G. And it ends with grouping. Grouping, okay. So, G grouping, grouping. Pair them up. Look at that first pair. Has a GCF of what? X squared. So x squared. Now, stop. We need to factor something out of that second pair where we're left with x minus 2. Negative 9. Good. Negative 9. So it's going to be x minus 2, because that's common to both, times x squared minus 9. Yeah, daggum, that's a difference of 2 squares. Daggum, I know. I don't always say it's a difference of 2 squares. I know you did. I know you did. So this bottom is x minus 2 times what? There you go. You betcha those x minus 2's will factor out. Now I'm going to write down what I got left. This is x minus 1 over x plus 3 times x minus 3. Now remember, everything we do from here on is going to come from this simplified fraction. Where is my whole? What is the x value of my whole? What is the x value that makes that equal to 0? 2. So 2 is the x value of my whole. How do I figure the question? Yes, it is possible to have multiple wholes. Yes, it is. I don't think we're going to have multiple wholes. I don't think so, but it is possible. Now, to find the y value of the whole, what do I do? Plug that x into what's left. All right, 2 minus 1. Now, the bottom's factored. That's fine. 2 plus 3 times 2 minus 3. What's this? Negative 1/5. Yeah. There's my whole. Vertical asymptote. Vertical asymptotes occur after I've checked for holes. Vertical asymptotes occur where? When the denominator is 0. Good. That's right. Oh, snap, I got 2 vertical asymptotes. X equal 3 and x equal negative 3. So I got 2 of them. Horizontal asymptote. Remember, listen, you take your notebook home. Well, no. Remember, to do horizontals, you compare the degrees. Now, We're gonna, I could do, listen, I could do either one. I could compare the degrees with what's left, or I could compare the degrees with the original. I'm gonna get the same horizontal asymptote. Let's compare them here. What's the degree of the top?
2.
What's the degree of the bottom?
3.
Degree of the top is 2, degree of the bottom is 3. If the degree of the top is smaller than the bottom, look in your notes. It's y equals 0. Y equals 0. Now you're saying, well, Steny, why can't I do that out of the simplified fraction? You can. Let me show you. Look. What's the degree of the top? 1. Now, the degree of the bottom is kind of hidden because you would have to FOIL. What's x times x? X squared. So what's the degree if that's an x squared? 2. And 1 is smaller than 2. Top is smaller than bottom. Y equals 0. Now go in and let's put in everything we've got. We've got a hole at 2, -1/5. We got a vertical asymptote at x equal 3. We got a vertical asymptote at x equal -3. We got a horizontal asymptote at y equals 0. And that's what we got. How many sections? Okay, so 3 sections. Now, so we're looking here. Let's look there first. All right? I've got to erase so I have some room. Let's look there first. X, Y. Come up with 3 x values that are in that area. Great. -4, -5, -6. Go to your calculator. You're going to have to type that equation in. Now you can type in the simplified equation, or you can type in the original. It won't matter. What x values or what y values are you getting? I can't hear you. So -0.7.
I guess I.
What else? -0.4.
Yeah.
Bottom. -4, -0.7, -5, -0.4. So they're getting closer. Do you know what that piece looks like?
Yeah.
It's going to go like this. Listen, our time's going to run out. But listen, ho. You're going to pick, you don't have to pick 2 numbers there because you've already got 1. You've already got the whole.
Yeah.
And then pick 3 numbers over here. But you have the table on your calculator, so you can do that.